So today's class will be focusing on chemical reactions, chemical equations, conservation of mass, and state symbols. So to start with chemical reactions involve the formation of new chemical substances. And they also differ from physical changes because during physical changes, what you see occurring is only change in state. No new substances are being formed. And in a chemical reaction, the atoms present in the reactants are rearranged and joined together to form the products. So what's the chemical equation? So the chemical change taking place during a reaction can be represented by a chemical equation. So we use chemical equations to show the change from reactant to product or product to reactant in a chemical reaction. So a diagram representation of this would be reactant reacting together to give us products. So reactants are found in the left hand side of the reaction, left hand side, and products are located in the right hand side. This is for all reactions, and the arrow here shows us the direction of change. This reaction right here is a one-way reaction. So in some cases we can have a twofold reaction. We call that reversible reactions in chemistry. Reversible reaction. Because you can go from reactant to product and also from product to reactant. So the law of the conservation of mass states that the mass is conserved in a chemical reaction. So what that means is that the number and the type of each atom in a chemical reaction must be the same in the reactants and in the products. So for example, let's consider the reaction that will give us water, which is hydrogen in its gas state reacting with oxygen in its gas state to give us water in the liquid state. So what we can see here is that, first of all, let's examine the reactant and the product side. And the product side. So in the reactant, we have 2 hydrogens, 2 oxygens. And in the product side, we have 4 hydrogens and 2 oxygen. So as you can see right here, our equation is not balanced because we have 2 hydrogen in the reactant side and 4 hydrogen in the product side. So to make the reaction balanced, we have to add 2 in order for hydrogen to become 4. So we have 4 hydrogen in the reactant side and 4 hydrogen in the product side. We have 2 oxygen in the reactant side and 2 oxygen in the product side. And the type of atom is also the same because we only have hydrogen and oxygen in the reactant side, and we also have hydrogen and oxygen in product side. So this confirms the conservation of mass rule because then both the number and the type of elements are the same in the reactant and in the product side. So I have a little tip for you. So you see this equation right here. I brought it here to tell you that the numbers in front of the formulas in chemistry we call them stoichiometric coefficients. What did I say? Stoichiometric coefficients. And they tell us the molar ratios of the reactant and the product in a balanced equation. So these are the stoichiometric coefficients. So I'll be talking about molar ratios in another video, but for now let's know that these ones are called stoichiometric coefficients. And and for example, in an exam situation, when you're told to balance an equation like this, and you're told to add the coefficients of the formulas, remember that what this means is you have to add the coefficients. So we have 2 for lead nitrate, plus 2 for lead oxide, plus 4 for nitrogen dioxide, plus 1 for oxygen. Remember that even though there is no number in front of oxygen, we can't see, but there is 1. So do not make the mistake of not including 1 in your calculation. So this calculation would give us 9 as for the sum of the stoichiometric coefficients. So I'll make another video on how to balance chemical equations from simple to hard. So state symbols. So state symbols, I have discussed it in one of my other videos. So in chemical equations, state symbols show us the state of the reactant or the product. So we have solid represented by S, and some of the examples of solid would be calcium carbonate, for example, and liquid delegated by L, and we have bromine as an example, and we have gas, and the sign for it is G, and then carbon dioxide as an example. And then we have in aqueous solution, and the symbol is AQ, and we have sulfuric acid aqueous. Aqueous is basically when you dilute a concentrated form of a substance, you make it aqueous. You will have noticed that the formulas of some elements are not simply their symbols. So for example, you cannot write hydrogen as H because it exists as a diatomic element, and oxygen as well, and nitrogen as well, and group 17 elements, also called the halogens, the fluorine, chlorine, bromine, and iodine. So you have to add 2 down here when you are writing chemical equations with these elements. So these are the 7 diatomic elements that you should be aware of when you're writing chemical equations. So that's it for this video. I'll be back with another video. My next video will be on balancing chemical equations. Thank you for watching, and please subscribe.